Hello students, and welcome to yet another video on fundamentals or foundation course on business statistics. In this video we are going to go through graphical representation. Basically we are going to look at two graphical representations. One is histogram and second is frequency polygon. So what is graphical representation of data? Basically it makes frequency distribution or time series easier to interpret. And we all know that whatever your eyes graphically can pick, it's very difficult to understand through numbers. Okay, something which comes in front of you as a graph, visually you pick up the trends, you pick up the patterns, you immediately pick up the outliers as well. So data, it's very difficult. Number, it's very difficult to pick up the outliers. But you know, graph immediately outliers, patterns, trends gets featured, gets understood so easily. So common graph types, as I said, we are going to look at histogram. It is basically used for continuous frequency distribution. We know what continuous frequency distribution are. Class intervals are depicted at x-axis. So just to give you an example here, if this is what it is, so x-axis, right, and you have y-axis. Your class intervals are depicted here on x-axis, and on y-axis you actually have the frequency figures, frequency values are depicted on y-axis. Um, there are no gaps between, in histogram there are no gaps between the graphs, between the bars. So histogram typically would appear something like this, right? And what this is the rectangle. You would see these are all rectangles, and basically this area of this rectangle is proportional to the class frequency. So that what it really means. So we'll see some of the examples on next slides. So we have an example. We have basically four classes. Let us try to depict it on x and y axis. Okay, so bear me for my straight lines. I will try my best to make it understandable. Okay, so this is, say, for example, 1, 2, 3, 4, and 5. Basically, I have depicted 0, 0, 0 because these are in thousands. So my x-axis values are depicted in 0, 0, 0, whereas this is my, so this is my x-axis, right? And this is my y-axis. Now I have y starting from 5 and it's approximately goes to 20. So 5, 10, 15, and 20. If these are my frequencies, right? If these are my frequencies on y-axis, so 10, 1000 to 2000 frequency is 15. So this is how I will draw it. So 1000 to 2000 frequency is 15. Now 2000 to 3000 frequency is 18. 18 is somewhere here. So what I do is I don't put any gap. I just put 2000 to 3000 frequency is 18. 3000 to 4000 it's 12. So if this is where my 12 is, so this is how it is. And 4000 to 5000 it is 5000. So this is how my histogram will look like, right? And these are, so if you see the area of this rectangle, okay, is proportional to the frequency of this particular class, whereas area of this rectangular is proportional to frequency of this particular class. So this is how histogram would look like. Okay, So let's move on. Let us take, so basically this example where was for equal classes, right? So if you see, my classes had the interval, same interval across. Now what if I have unequal classes? Say for example, these are my examples of classes: 10 to 15, 15 to 20, interval here is same, 20 to 15, 20 to 25, sorry, this is 25, 25 to 30. Okay, so all four top classes have interval 5, whereas this is 30 to 40, interval is 10, 40 minus 30 is 10, 60 minus 40 is 20, interval 20. Now, if you notice in this particular data, I have classes which are unequal, right? Now, in that case, how do I draw a, a, a histogram, right? So let's try to depict it. This is my y-axis, this is my x-axis. So I have 10, 15, 20, 25, 30, 35, 40, 45, 50, 60, 65, 70, 75, and 80. 10, 20, 30. Let me take it 10 to, sorry, I would have to take it 10 to 15, 15 to 20, 20 to 25, 25 to 30, correct, 25 to 30, then 30 to 35, 40, 45, 50, 55, 60, 65, 70, 75, and 80, right? Now, for 10 to 15, let's see frequencies. My frequencies are between 5. So if I take 5, 10, 15, 20, 25, and 30. So these are my frequencies. So 10 to 15, my frequency is 7. So somewhere here. So this is how I will depict a bar. This is my 7, somewhere here. 15 to 20 is 19. So it would be less than 20, just below 20, somewhere like this. So 20 to 25 is 27. So somewhere here, that is 27, right? Now 25 to 30 is 15 again. So somewhere here, like this. Now 30 to 40. Now 30 to 40, now this class is large, right? So what do I do actually, right? My frequency is 12. And if I divide this 10 by 5, I get 2. So basically, there are two intervals here. This is one interval, this is two interval. So what do I do is, I divide the frequency, which is 12, by 2, that I get 6, and my height will be 6. So I will take my height 6, and I will draw my rectangle like this. So basically, my rectangle has horizontally increased because I have two intervals, but I have vertically decreased my rectangle by equal proportion, that is by dividing by 2. Since horizontally it is increased by 2, I have reduced my frequency from 12 to 6. Okay, then next is 40 to 60. So 40 to 60 is 1 interval, 2 interval, 3 interval, 4 interval. So I have 4 intervals. So what is my frequency? My frequency is 12. So I will take 12 divided by 4, correct? So basically it is 3. So this is what my frequency would look like. This is what my 3 less than 5. It should be less than 5. If it's not looking less than 5, it should be less than 5. Yeah, so 3. Okay, and this is how you are going to develop your histogram. Just look how proportionally I am decreasing my heights. So whenever I have my uh, classes which are larger than the normal classes, when the class intervals are larger, okay, and typically they would be in multiples of the base class intervals. So this is 5 to the 10, 5 fours are 20. So that multiple I need to divide my frequency with, and I will get, uh, I need to reduce my height accordingly. Okay. So moving on from histogram, let's see what frequency polygram. Polygon is a line graph representing frequency distribution. It's useful for comparing multiple distributions on the same graph. So basically it's a kind of line graph, right? So you basically depict the points and connect them, and you can then have multiple line graphs which you can compare on the same graph, right? So multiple distributions on the same graph can be compared. Okay. For discrete frequency distributions, you have x-axis as variable values and y-axis as corresponding frequencies. Discrete is pretty simple. On x-axis, you will have your variable values. On y-axis, you will depict the frequencies, and you just have to connect the straight lines, connect the dots with the straight lines. Okay. For grouped or continuous frequency distributions, you have two methods to draw. Method 1 is through histogram. We already saw histogram. So you can draw histograms, right? And then what you have to do is you take the midpoint of your rectangle and connect that midpoints, right? So that becomes your polygon. So this is how you will connect, okay, the midpoints of your rectangles. Okay, so first draw the histogram and connect these points. And without histogram, use the midpoints of the class intervals. So instead of this, whatever your class interval is, use that midpoint and directly depict the point. Okay, and then join the dots. Let's see a couple of examples. So this is a very simple example. Okay, very simple example, but let us quickly do it. On x-axis, I have 1, 2, 3, 4, 5. So these are discrete values, right? They are whole numbers, discrete values, fundamentals that we have seen in our very first video. Okay, so on y-axis we'll have, say for example, 10, 20, 30, 40, 10, 20, 30, 40, 1, 2, 3, 4, 5. So 0 is 40, this is 0. So this is my dot for 0. 1 is 30, it's here. 2 is 35 in between. 3 is 25 here in between. 4 is 20 somewhere here, and 5 is 20 again somewhere here. So all that I have to do is I have to connect my points with straight lines, okay, and like this. So this becomes my frequency polygon for discrete frequency distribution. let's move on to next. Now here what we have is we have classes. Now let me ask you a question. Are these classes inclusive or exclusive? Yes, you are thinking right. These classes are inclusive because there is a gap here. Okay, and both 20 and 24 is included in one class. Now we, since it is a, a continuous variable, we need to convert this into continuous number, continuous classes. So what we have done, if you remember, find out the gap. Gap is 25 minus 24. So gap is 1. So 1 divided by 2 is equal to 0.5. And then I reduce 0.5 from lower limit of the class, and add 0.5 to the upper limit of the class. And that's where I get 19.5 and 24.5. And I go on repeating this everywhere. Correct? So let me quickly depict this graph. Now this is 0. Now look at this. The first class starts from 19.5. Correct? So I can take 14.5 here, which would be the lower of previous class probably. Okay, then we have 24.5, we have 29.5, 34.5, 39.5, and 44.5. Now remember one thing, since we are starting this from 14.5, it is not scaled appropriately. So the best way to do it is to mark it like this, because 0 to 14.5, okay, is not scaled, whereas after 14.5 you have equal intervals, right? 24.5, 29.5. All right, okay. On y-axis I have 5, 10, 15, 20, 25. So just get 5, 10, 15, 20, 25. So let me start. So 14.5 will be 0 because I don't have anything in this. 19.5 will be 5. So I will depict it like this, right? So basically this is how I will go and draw a histogram. Correct? Then 24.5 to 29.5 is 12. It will be somewhere here, right? So if I take it here, this is how it will be. This is 20, 29.5 to 34.5. This is 15, 15, and this is 39.5 to 44.5 is 8, 8, and last 49.5, it is 5 here. What do I need to do is I will take the midpoint of every rectangle. I'll take the midpoint of every rectangle, and all that I have to do is connect the midpoint of all the rectangles with a straight line, and this becomes my frequency polygon. Okay, with this we come to the end of this video. Thank you so much for watching, and keep on watching the videos. A new one will follow soon. Thank you.